Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the week 7 of this ongoing course on understanding and reducing greenhouse gas emissions, and we are focusing on this emission reduction through building design and construction. In this lecture today, we are going to look at the factors which affect material selection in building. So, we are not just selecting the materials looking at emissions point of view, but there are a lot of primary factors which govern which material will be useful in a particular scenario for a particular context, and in addition to that emissions, how much emissions do these materials cause, the choice of material cause is an additional factor which we have to always keep in mind. So, this is what we are going to look at today. But before I go ahead and discuss about the factors which affect selection of materials, the first thing that we have to know is why at all are we talking about materials. So far what we have done in the previous week is we have looked at different passive design strategies. We talked about thermal comfort, we looked at different passive design strategies and advanced passive design strategies. Then we looked at natural and mechanical ventilation, what are the combinations that we can have and how can we enhance natural ventilation, and also daylighting. Now, all that we saw in the previous week was mainly design oriented. We were designing the building to be energy efficient. Now, look at the content of the previous week which we have here. So, what we are seeing here is that we are looking at the thermal comfort, and then we are looking at these strategies, passive design strategies to enhance thermal comfort. So, we are talking about enhancing thermal comfort, and what will it do? So, it will reduce the energy consumption, which in turn will reduce the emissions. So, this is what we are talking about. So, we want to reduce the energy consumption through building design. Now, all this is actually going in scope 2, but the scope 2 is tremendous for different types of businesses, different types of companies, as we have already seen in the week before that. So, what we are trying to do through the strategies that we saw in the previous week was we were trying to reduce the scope 2 emissions, which are directly going to accrue because of the amount of electricity or energy, different forms of energy that we are going to use. For example, we might be burning conventional fuel to heat up a building. So, that is also, so there it could be scope 1 if we are burning the fuel on site, but largely it is going to be scope 2 because majority times the buildings today are being run on electricity. So, it is either scope 1 or 2. Then we also looked at ventilation. So, if we do not have enough natural ventilation, we will be adding the mechanical ventilation, or we will be adding the HVAC to serve the purposes of both bringing in thermal comfort as well as the ventilation requirements. And then we have daylighting strategies. Here if we are not designing well, we are going to use artificial lighting. All this together is actually giving us this. So, what we are trying to do is we are trying to enhance thermal comfort or visual comfort, or we may be talking about the indoor air quality at large. So, we are trying to improve the comfort inside the buildings, and in process of doing so, we are reducing the energy consumption in the building, and which is further leading to reduction in emissions, which are largely in scope 1 and 2. How much reduction is going to happen when we are talking about emissions, that we will see in the next week, where we do the calculations that if we select one particular strategy, then how much reduction can we accrue, can we get, is going to come in the next week. But so far we understand that these passive design strategies are going to bring us scope 1 and 2 emission reduction, which is the primary focus of this course that we have been studying. But in addition to that, what we are also going to see is we are going to see the factors which are going to affect the material selection in buildings. Now, the material selection, these considerations for material selection in building, and when we go forward and we look at the low emission materials, we will largely be looking at reducing the scope 3 upstream emissions. So, these different materials, the choice of materials that we have. So, out of that, if we select materials which have high embodied energy, which means they are associated with a higher rate of emissions, and hence all these emissions are going to be counted as part of scope 3. However, while the focus of this course which we are studying is scope 1 and 2, and the calculations are largely going to be on them, but we are also looking at this selection criteria of materials, so that we can reduce the upstream scope 3 emissions also. Now, there are several factors which affect the selection of material, and we can broadly categorize them into 4 categories. The most important is the mechanical and non-mechanical considerations. We will come to the details of what all are those factors exactly, but these are the primary factors for selection. And then we also have the economic consideration. So, there are not too many factors which go into economic consideration. We will look at those factors also. So, primarily these two often they drive the selection of materials. Which material to select? We are mainly looking at these two. Then we are also looking at the production and construction. This is where most of the sustainability part comes in. When we are talking about green buildings, the selection of materials is actually being driven from the parameters considerations here, and of course, we have the aesthetic consideration which is kind of an underlying thing which always stays there. Now, if we look deeper into these factors, what we would see, the one which is most important, without this the buildings cannot function well. So, what we are looking at when we say mechanical and non-mechanical considerations is that we have to check the strength, their durability, what kind of maintenance requirements do they have, their specifications and their performance in terms of it could be thermal performance, visual performance, acoustic performance, because when we say glass, there are varieties of glass which are available in the market today, but their performance, their visual performance governs which one to use. We have just seen that. Then we are talking about maintenance. So, there are certain materials which require a lot of maintenance, and that is why they are not very common in use these days. So, a lot of materials which qualify on a lot of different other criteria, but they require a lot of maintenance, they are gradually going out of the market. People are not preferring materials which require a lot of maintenance. So, well, we will come to each of these factors in detail now, but these are some of the factors, and there could be a number of other factors which we can include in this list, but these are the primary factors which can be considered within mechanical and non-mechanical considerations. The second one which we said is the economic consideration. So, some of these factors, for example, durability affects the economic consideration too. So, but if we look at the two primary factors, we are looking at the capital cost of material. How much cost am I going to incur in the beginning when we are purchasing that material, when we are going to be procuring that material, which adds to the capital cost of my building. And then we are talking about warranty or guarantee, and this durability actually affects this. So, if we have a durable material which is going to be there for 20, 30 odd years, but we have to pay small premium for that durability, for the warranty and guarantee that comes along with the material, we might find it more economical than if a material is staying only for say 2 or 3 or 5 years, and there is a slight reduction in the cost. So, that cost comparison, so we are talking about the life cycle cost of the material. So, the economic consideration, one could be the upfront cost that is going to be charged to the person, and the other one could be the life cycle cost. So, we are not talking about the cost of emissions and others, but only during the installation of the material. So, the cost for procurement of material and then for operations and maintenance. So, that is the cost, life cycle cost, the cycle that we are looking at, and that will also be an important criteria. Now, other than that, we have aesthetic consideration, which is always going to be there, but this is a subjective factor, and we can have a lot of debate over this, and in fact a lot of decisions which eventually affect sustainability, emissions, all these discussions that we have been having. So, they are often governed by this perception of aesthetics, what is beautiful. So, if we go around the world, we would find, so that the perception of aesthetics has changed over time, it keeps changing. So, earlier people would find stone clad buildings beautiful. Gradually, as we are moving forward, we are finding more and more metal clad and glass clad buildings, and they somehow seem to appeal, and that is how we are coming up with more and more such buildings. So, this perception, aesthetics is more about perception, what is being perceived as beautiful, aesthetically pleasing, but this will often form the fundamental basis of selection of certain materials, but we have to argue that along with the other considerations. The another set of factors which are extremely important but often find neglected are the ones which are in the category of this sustainability. Largely they drive sustainability. For example, the local availability. So, if the material is locally available, and a lot of these green building rating programs, they advocate, they mandate the use of local materials within 500 kilometers. Now, that itself is a far wide range, and we may have arguments there, but the local availability reduces a lot of upstream emissions, because the transportation costs are significantly reduced, and we have seen that a majority of the total greenhouse gas emissions are because of the transport sector, because there is a direct fuel which is burning for transporting goods. So, if the products are locally available, if they are being manufactured locally, we are looking at the scope 1 reduction during the manufacturing process, and if we are looking at the entire building as a product, we are actually looking at lesser embodied energy, lesser carbon emissions upstream. Then we are looking at some other considerations, for example, climate. So, what is the climate of the place, and then we select the materials accordingly to suit the climatic context. Their recycling potential, can the material be recycled and can it be reused after recycling? The nature of the project. So, typology of the building, whether it is a daytime use building or it is a 24-hour use building, it can function as a naturally ventilated, or it has to be air conditioned. So, what type of project are we looking at is another factor which should govern what material to be selected. Then we are looking at the handling and storage of the material. This includes the wastage that is going to be there when we are handling the material, and how easy it is going to be to work with. So, we are talking about the skill set that is required to use a certain material. So, all these factors are coming under this production or construction considerations, and we have put sustainability as a separate factor, which sometimes includes some of these factors, but other times we are actually talking about the emissions that are going to accrue from the production of the material. So, we are looking at the emissions during the process of manufacturing of this material as a most significant factor under these considerations. So, these are broadly the factors that we consider when we are looking at materials, when we are going to select a material. Let us look at all these factors quickly. I have discussed, I am not going to go in detail over it, but basically what we are looking at when we say cost is the upfront cost, which we say capital costs. So, two costs we are looking at. We are looking at the capital cost, but at the same time we are also looking at cost benefit analysis. So, we look at both these things, not just the upfront cost, the capital cost, we are also looking at cost benefit analysis, that over the years what is going to benefit me. But often we neglect this cost benefit analysis because of the fact that the building is being constructed by one party and it is going to be used by another party in most of the cases. Unlike residential buildings, and here also I am not talking about apartment buildings, single individually owned residences where the owner is also the client who is commissioning the project, and then he is going to stay in that. So, that number is significantly reducing. Other than those, majority of the times the party, the concerned party who is constructing these buildings is not going to be the owner. There the person, we are talking about developers or construction companies or real estate people. Now, there for them the capital cost is the only concern, that is the concern. Now, they are not concerned whether the selection, the usage of this material is going to consume more energy for creating, for maintaining a comfortable indoor environment. All they are concerned is with capital cost. But if we have to genuinely do the selection of the material for a long term benefit, then we have to look at the cost benefit analysis. This could be done in multiple ways, but one mandatory thing to do is what is its effect going to be on the energy consumption, which will give us the cost benefit analysis a lot of times. So, the upfront cost plus the operational cost that is going to incur because of this selection. So, this is what we are looking at when we say cost. And the second one within this cost consideration, the economic consideration, is warranty or guarantee. So, we are talking about durability. What is the total life of the material that we are going to use? Now, a lot of building materials, for example, the basic walling materials and roofing materials, they often have a long lifespan. So, they continue to remain in use for another 50 or 80 odd years. The bricks, the stone, the concrete, so they all have a long life. When we say warranty or guarantee, we are talking about building materials or also components which have a shorter life. So, we are talking about materials, for example, glass, or we are talking about metallic sheeting. So, all these materials we are going to be concerned with the warranty or guarantee that is going to come with these materials. Again, it is going to affect the cost benefit analysis. So, if I have a material which is going to get replaced after 10 years, I will have to replace, for example, the sheeting or maybe I may have a wooden panel, outdoor wooden panel. Now, that may have a shorter life when it is exposed to weathering, every year, every season. So, that will have a shorter life. How much cost I am going to incur on that, and the savings that I am going to have from operational operational savings. Along with that, the life of the material is going to tell us that how much is the benefit. The next factor, we are moving on to the mechanical factors, mechanical and non-mechanical. The most important factor that we will always use is this strength. Now, strength for various purposes. For example, if we are making multi-storied building for residential purpose, it is having a different set of requirements, different strength criteria are required. Compare it with that of a bridge. If we are going to have a long bridge which has a long span, the two buildings, the two structures have different requirements for their strength purposes. This one requires different type of material, and this one requires a different type of material, strength being the primary criteria. Not every material can be used to make a long span bridge. It can, there are few materials that are there. Now, when we are looking at this, we can compare only between those materials, and we cannot say that, oh, this is a high emission material. So, we cannot compare bricks with steel when we are talking about bridges. Yes, we can talk about them depending upon the spans. We have seen masonry bridges for a long time, long time we have been using masonry bridges. But now we move on to steel, and there are several benefits that come along with steel. So, when we are talking about strength or as a primary criteria, then we are comparing only with materials which have similar strength, and the purpose is defined, which is primarily strength. If we are talking about, say, a single storied residential building, in that single storied residential building, of course, we have this vast array of materials that are available, right from the CSEB, the stabilized earth blocks, to even metal, steel is available for residential buildings. But which ones do we use depending upon the strength requirement is what we are going to talk about. So, we look at the strength of different materials. It could be compressive strength, it could be tensile strength depending upon the purpose, as I said clearly. Then durability. Again, we are talking about the life of this material. How long can this material serve? How durable is it? So, for example, if you look at materials such as brick, the fired clay brick I am talking about, if it is properly made, if it has been manufactured properly, it has a very long life. You must have heard that the bricks from Indus Valley civilization, from Harappa and Mohenjo-daro were discovered, and in fact, they were discovered, people found out that there was a city because they started taking out those fired clay bricks. They continued to remain after 3000 years also, they continued to remain in such good condition that they could be used even further in buildings, in the railway track that was actually being done. So, but then steel is not a material which will have such long life like 3000 years. It will rust, it will corrode, and it will totally disintegrate. So, we have to look at the durability of these materials, but we also have to see along with that the purpose for which it is being designed for. Now, a structure which is surely not required to be there for 3000 years, like that long year, of course 3000 is too long a time, but then we look at the lifespan which is desired for a building. The residential buildings may be having a higher, the commercial buildings may not be requiring that longer lifespan because there is newness which is required to continue running a business. So, we might be wanting the buildings to be there having a particular look for a limited period of time, after which we would want to change the facade. Now, do we really need that longer durability, when that longer life, when we are talking about the overall lifespan? So, there we have to see that which materials should be used. Now, when I was talking about the factors initially, for example, mud, unbaked raw mud. Earlier you would have seen that the houses in rural areas, the kacha houses, were actually done using the mud. Now, the problem with that was, of course, the strength was an issue, but for a single storied building it still had enough strength as much was required to serve the purpose. But the durability was a problem. Every time there would be rains, there would be excess moisture in the atmosphere, this material will start to disintegrate. So, the durability was not there, and it would the similar thing was with the roofs, kacha roofs, thatch. Now, the problem with thatch is that it is not very durable. A very good quality roof done in thatch might stay for 5 years, 6 years, 7 years, at max 10 years, and after that we have to change it. Now, this is one deterrent in using some of the organic materials, because organic materials, we are talking about construction materials here, organic materials often will decay unless they have been seasoned really well. For example, wood, if it is properly seasoned, it will have a very long life, it is very durable. But some other materials, organic materials, majority of them are not as durable. So, we are looking at strength and we are also looking at durability, and everybody wants durability for their structures. But having said that, we still have the options, we can select carefully. For example, for indoors, we can always use wood. provided it is procured from sustainably managed forests. So, if you have studied about the concept of forest stewardship, so we are talking about sustainable management of forests, so that the supply of wood from these forests is sustainable, we can sustain it. We cut down 10 trees and 10 trees are ready, fully grown, mature trees. So, that is the sustainably managed forest and the wood procured from that. If it is a material like that and it is going to be used indoors, it is going to stay for a very long life, for a very long duration. It has a long life, it is highly durable. Now, we have to decide where to use which material. Of course, outdoors it may not have that longer life, it may not be very durable, but indoors it is. So, we have to look at all these factors simultaneously. We can't just say that no, I was looking for strength, so I just went ahead with steel. For the given requirement of strength, can there be other materials which have less emission factor, which are fairly durable, and there are other benefits? That is what we are talking about. Then of course, maintenance. Again, as I said, that maintenance is one thing which has been a major deterrent in the use of low embodied energy or low emitting materials. For example, the mud blocks. So they are very good environmentally. They have sufficient strength as required for a single story or a double storied building, but the problem is that they require a lot of maintenance. As I was just mentioning, that every rainy season, after every rains, they would require to be maintained properly. It is a task. Compare that with the modern homes that we have today. We have bricks, pakka bricks, fired clay bricks, we have concrete, we have all those permanent materials. You construct a house and it does not require as much of maintenance for next 50 years, except for some painting here and there. Compare it with steel construction. It practically requires no maintenance, again little bit of paint, and if it is properly done, if the composition is good, probably you would not require to paint it as often as you would require to paint the brick buildings. Now, maintenance therefore plays a significant role, and today as we are shifting to lifestyles which are very fast moving and people are switching more and more from traditional jobs to white collared jobs, people have lesser time to maintain the buildings, and that is why we are, and also the economy supports, economic growth is supporting. So, we are going towards buildings which require less and less of maintenance. Besides this, the social requirement of having buildings and materials which require less maintenance, there is another side of it, that maintenance also costs. So, there is a maintenance cost that is associated with certain materials. Every time we have to maintain, it consumes resources, either it would be consuming manpower or it would be consuming material or energy, but it consumes resources. So, we want materials which require less of maintenance and associated resources. Then we are talking about the specifications. Now, here we are talking about all these factors that we have just discussed, the strength, the durability. How do we know that which is the material which will be suited for this purpose? As I said, okay, a bridge which spans say 750 meters, which material to be used? We need material which will have a strength of at least this much depending upon the design. So, we have to clearly specify when we are saying, okay, I need an acoustically insulated room. I am in a recording studio right now, and there it is all insulated from all sides. The specification that I have for the internal cladding is that I have to have an acoustic insulation in place. What all options do I have available will then be evaluated on other parameters, but the fundamental specification has to be put in place. In fact, this should be the first factor of all, and further some of the factors will then become important. Here it is the acoustic performance, for some other building it could be strength or durability or something else. And then we have performance. So, what all performance? It could be thermal performance. So, suppose we are talking about buildings in Alaska. There is probably minus 40 degree centigrade temperature outside, and inside indoors we would want, even if we are talking about adaptive thermal comfort, we would want some 20 degree centigrade inside. We are talking about a temperature difference of 60 degrees from outside to inside. How do we maintain that? So, the mandatory performance requirement for the building would be, for the material would be that it is an insulating material, it has thermal insulation properties. So, that is the performance criteria and that will go as specification. I am in recording studio, the performance criteria is that it should have this much acoustic insulation that it provides. How much insulation should it provide? If I am having, say, an operation theatre or maybe a museum, I do not require certain wavelengths of light to be falling onto my exhibits. The colors fade, maybe it is an art gallery. So, I need specifically only a limited wavelength, the light for a limited wavelength to be permitted inside and the rest of it to be cut off. The UV is not required at all, it has to be cut off. So, this is my performance criteria and so the specification would be a spectrally selective glazing. So, we are talking, when we say performance, we are looking at specific performance criteria and then we will frame the specifications accordingly and define the rest of the factors. Now, which factor takes precedence depends upon the context, the building that is in question. The next one is this category which is broadly under the production and construction category, and here whenever we are talking about sustainable buildings or green buildings, we must look for materials which are locally available preferably, and that is there are multiple benefits of that. We are looking at it from the point of view of a client who owns the building or is wanting to construct the building. For us it will be cheaper, one, because there is less transportation cost. So, automatically the preference would be local materials. Unless we have specific structural or performance requirements, we can do with local material. That is from the client perspective. From the socio-economic point of view, if we see, when we say that we have to mandate or we are mandating the use of locally available materials, what we are really doing is we are decentralizing the production of materials. So, locally the economy would grow, but of course, there are limitations to it. Not we cannot produce bricks everywhere. The soil may not be of good quality everywhere. We can't produce bricks in the extreme coastal areas because there is less clay that is available and there is more of sand, or in deserts the brick kilns cannot be established, but what can be established is probably AAC blocks. We can, or maybe glass factories, but of course it requires water. So, that is what we have to see, but in general if we are talking, if we are promoting the use of local materials, the smaller factories would come up and it will provide opportunities in all the areas, is what we are talking about from socio-economic point of view. From a client point of view, it is going to cost me less, and from an environmental point of view, from a nation's point of view, as we say India is heading towards a net zero emission status by 2070, it aspires to do that. So, if we are looking at that, we are looking at least the minimum is reduction of transportation emissions. So, this is what we are considering when we say local availability. The next is climate. We have discussed a lot about climate, but even after discussing that, and climatology is like a fundamental subject in architecture, majority of the times when we go on to design, we do not consider climate while selecting the materials. You would find a lot of metal and glass clad buildings in extremely hot dry climates within our country. You would find buildings which are totally closed, enclosed, no openable windows in extremely warm humid regions of our country, which can function really well if they are naturally ventilated. So, unfortunately, when we are selecting the materials, when we are designing the buildings, the climate, the understanding of climatic context and the requirement takes a back seat. we have to put it in the front and we have to design and select materials accordingly. And all of this, a lot of this is going as part of sustainability, plus the emissions that are going to be associated with the manufacturing of the material right from the raw material extraction. Compare CACB, which is a very low emission material, compressed stabilized earth block, 5% of cement, the locally available clay, which is anyways going to be there when we are excavating for the foundation of the building, and a machine which can work manually or maybe with some little amount of energy to produce the blocks. Compare it with, for example, glass. Now, we have a lot of raw materials that have to be extracted and then transported, because we are talking about a lot of additives, metallic additives, we are talking about sand. All these raw materials will be extracted and then transported. So, we are talking about raw material extraction and transportation to the manufacturing site, and then we are talking about the manufacturing of this material. Here we are talking about, when we say CACB, is manufactured on site, zero transportation and minimal amount of energy to be required, even if it is going to be an automatic process. Compare it with glass, where the sand will be required to be heated to some 1400 degrees centigrade to fuse it, to melt it to become glass. We are talking about two extremes of the materials, and this is going to cause so much of emission in that process that by virtue of all this energy that is going into making this material has become unsustainable. And then we may be requiring more energy and more processes for assembling the material and then supplying it. When I say this, and I am giving you two extreme examples of CACB versus glass, and I clearly say that from environmental point of view, when we say here sustainability, we are talking about environmental sustainability largely. We are not taking into consideration the other factors, because you cannot absolutely discard a material like glass. It comes with a lot of benefits. For example, daylight, connecting. You can't just block the entire wall using a CACB just because it is highly sustainable, environmentally sustainable. We will still have to use glass where glass is required, but how much? Where all can I use it? Which climates do I use it? How do I design it? All these factors and considerations have to be brought together. In isolation, no material is sustainable or unsustainable. In certain cases, for example, stone is, we will see in the coming lectures, stone is associated with very low embodied energy compared to other materials. If we talk about the industrially produced manufactured materials, compared to them, stone has a significantly lower embodied energy and carbon footprint. But if we look at the environmental impact today, majority of the countries are banning the use of stone, because it is causing habitat destruction, ecological imbalances. So, while emissions is one criteria, there are a lot of other parameters which might be associated with the manufacturing or extraction of this material. So, from embodied energy or emissions point of view, stone seems to be environmentally more sustainable, but if we look at it holistically from environmental impact point of view, then the stone is not highly sustainable today. So, we have to look at any material, use it by after considering all the factors that we have been discussing. Recyclability is one factor that we can surely consider in today's times, because one, that the buildings, as I said, we want, especially for commercial buildings. So, especially for commercial buildings, we are looking at facades which can be renewed faster, newness to be maintained. So, if we have materials which can be recycled and put back into usage, is something that should be preferred. Now, glass as a material, metals for that matter, they can be recycled, but of course, the other factor that they are associated with very high embodied energy and emissions is something that we have to keep in mind even when we are talking about recycling. So, if we look at the emissions for a recycled product, then we see how much of total emissions does this material have. If we consider 10 years life span, and then it goes into recycling and another 10 years and goes into recycling again and another 10 years. So, we have to look at the potential for recycling for all the materials. And of course, nature of the project, as we have seen, depending upon the purpose for which the building is being designed, and hence deciding on the performance criteria. What is the performance criteria? As I said, I am sitting in a recording studio. The nature of the project requires that I have to have acoustically insulated rooms, no windows, no connections, just insulated packed room. If it is a sports stadium, it is a different project altogether. We need larger spans, open areas. If it is a residential building, it is a different project requirement altogether. So, depending on the nature of the project and climate, we decide the performance criteria, performance parameters, and then we write the specifications and take into account all the factors that we are discussing. Handling and storage, it is another factor because it requires labor, it requires equipment. A lot of materials could be heavy, might be requiring a lot of extra machinery to operate, to handle them. So, we have to look at all these factors when we are selecting the materials. And availability of required skills. Often we do not take into account that as a factor, but it automatically comes up in the cost factor, because the moment we require highly skilled labor to install or to construct using a certain material, the cost will go high, the cost for labor will be much higher. A lot of materials have also been falling out of use, out of market, because the skilled labor is not required. For example, if you would see traditional buildings, you would see a lot of wood carving in place. Now, gradually as we are moving forward to more industrially manufactured materials, that skill is going away. The people who used to work are no more there, and so we are seeing a shift from the traditional materials to the industrialized materials as well. So, we are looking at the available, I mean, as a designer, as an architect, we might just propose using certain materials, but we also have to see whether there is skill available or not. And the last one, but not the least surely, is aesthetic appeal. Now, what kind of materials are being perceived as beautiful? The exteriors. So, if you look at the traditional buildings, earlier, we would see that you go to the hot dry region, the semi arid region of northern part of Rajasthan, the Shekhawati part. Now, here you would see that all the buildings from outside were plastered with lime. So, it was lime mortar that was used to plaster, very smooth surfaces and paintings done on the walls. So, when you walk through the streets of Shekhawati, the older towns of Shekhawati towns, you would see the streets, they look like open air art galleries where there are paintings on both the sides. That was the perception of aesthetics then, and everybody would get their houses painted, whoever could afford. Today we do not do that at all. There are very, very plain and flat looking exteriors, and they are perceived as beautiful, right. Along with the designing of the building, along with the geometry and massing that we have for the building, we also have the materials which are perceived as beautiful or sometimes not. Now, this is something, as I said, perception is something that can be consciously changed. That if I have a greater consideration for environmental factors, I would not like to have a building which is metal clad, or which is completely a glass building in a hot dry climate. Even while from the general perception point of view it might look beautiful, but from an informed user's perception it is not aesthetically pleasing. So, this is something that is very important, but it can also be changed, the mind can be trained to like certain things. So, we have to make the other factors, the factors of sustainability to be more relevant, and then select the materials, not purely on what the general perception of aesthetics is going. So, these are the factors that govern they determine which materials to choose and not, and we have to keep all of these factors into mind when we are making a choice for the materials. I will stop here, and tomorrow we are going to look at the examples of different materials for different building envelope components and even interiors, the roofs, the walls, the fenestration, and see what all options do we have available and how the emissions and embodied energy for each of these materials are changing, so that we can make a conscious choice of what material to select. Thank you very much for being with me here today. See you tomorrow. Bye bye.